All right, so picking up where we left off, we're going to start with this strategy, solving quadratics by factoring. We have the same trig function here, a sine squared and a sine x. So again, whenever you see that, you should think, I need to factor this. It's the same thing as saying 2x squared minus x minus 1. And if you can factor this, what's in the pink, then you can factor this problem here, okay? To factor this problem, I have to use what? California method. When you multiply 2 and negative 1, you get negative 2. So you ask yourself, what two numbers multiply to give you a negative 2? Add together to give you a negative 1. Negative 2 and 1. Remember we put a 2x on top, and we reduce. Does this reduce? To what? X minus 1. Does this one reduce? No, so that stays the same. So those are your factors. But instead of putting an x minus 1, you're going to put a sine x. And instead of putting a 2x minus 1, you're going to put a 2 sine x minus 1. Because instead of an x, we just have a sinus attached to it. Thank you. Plus 1. Questions on that? That's old. That's factoring. Okay, so add a trig function with it. Okay? So then from there, again, you have two factors. So what do? Zero product property. Set them both equal to 0. Sin x equals what? 1. And we are going to restrict this one from 0 to 2 pi because we did a lot of writing general solutions with like the first 7 examples. So we're going to restrict all these, just the answers between 0 and 2 pi. And actually, let's do it like this. What's the difference between a square bracket and a normal parenthesis?
That includes it, and then parenthesis does not.
Yep, 0 is included, but 2 pi isn't. And since 0 and 2 pi are the same place, it normally is written out that way. You wouldn't include both, but you just gotta look at the restrictions. So on our unit circle, where is sine 1?
0.
Sine 1.
Pi over 2. Because remember, sine is our x or y value. Y.
Yep.
Over here, we'll need to solve for sine x. It's going to equal a negative 1/2 because you subtract 1, you divide by 2, and now you think, again, knowing your unit circle, where is sine a negative 1/2? A negative 1/2. 7 pi over 6. I thought I heard pi over 6. And then these 3 would be your answer.
And that's because of the restriction, right?
Exactly.
So when it's restricted, you don't place
Correct. When it is restricted, you do not write the plus 2n pi or plus n pi or nothing like that. Okay, you only provide it within that particular domain. Questions? Let's get this one. I actually want you guys to try this one on your own. That's within the restriction. Alright, so this is another one set factors. Another California where you multiply 6 and negative 2 to get what? Negative 12. So you're looking for two numbers that multiply to give you a negative 12 that add together to give you a negative 1, negative 4, and 3. So then you create your fractions and you reduce, and then that gives you your factors, which were what? 3 cosine x at plus 2. Minus 2, and then that you would set equal to 0 and just double check. Yes. So then you'll set both factors equal to 0. solve for the trig function.
Where'd you get the two?
Because you were looking for two numbers that multiply to give you negative 12. They said it was negative 4 and 3. And then remember on top you put A and everything.
Why are we adding to get negative 1? Where does the 1 come
The middle term. Just like on the other one, it was the same thing. We were looking for two numbers that multiply to give us negative 2, but add together gives us negative 1. It's always the middle term. So when we solve for the trig function, it's going to be cosine x equals 2/3, and then cosine x equals now cosine 2/3. But where is cosine 2/3 on your unit circle? Is there any place?
I over 3.
2 over 3, not 3 over 2. Square root 3 over 2. There is not a place, an exact place where 2 over 3 is. However, if we did want to figure out what this x value would be, we would have to use our calculator. Okay? And there, you can do these types of problems in a calculator because isn't 2/3 less than 1? So it's not a no solution because it is less than 1. We could find this out, but we're not going to be using calculators on this unit, okay? So you leave this here, you don't put anything after this, you just go to the next one, okay? So when you run across that in any of your homeworks is going to be non-calculator for this unit. To be honest, I don't even know if you're going to use a calculator for the rest of the year, okay? So go to the next one. Where's cosine of negative 1/2?
Negative 4 pi over 3. And then 4 pi over 3.
And then those would be your two solutions. Okay? There would be more, of course. You know, it would be the decimal approximation of wherever cosine is as 2/3, but we're not concerned about that. We're only concerned about the exact ones. Questions? All right, so looking at C. C is another one that you can factor, but it's a tad bit different. Why would I say that it's a tad bit different?
Because it has a sine and a cosine.
You have two different trig functions. You have a sine and a cosine. But is there a way to rewrite one of them so that it has the other trig function? Like, close. It is 1 cosine squared x, but it's not a plus. It's a minus. Yes, you can rewrite sine x squared as 1 minus cosine squared x using the identities. Identities can be used in solving these problems. Okay? And so now you'll have all the same trig function. What do you need to do to that 2? Distribute. So that'll be 2 minus 2 cosine squared x minus cosine x equals 1.
Oh.
Can't take out a cosine because this doesn't have a cosine.
You gotta minus the 1.
We can minus the 1 over, and then we'll end up factoring. Okay? So what I want you guys to do is I want you to solve this one out. It should be in your pot. Okay? Alright. Now, if you did work with this as your square term being negative, that is totally fine. Me personally, I don't like working with it as a negative term, so I would actually write everything over to the side where 1 was. That's just so that my square term could be positive. It's just easier for me to work with. Okay? But our solution still be the same if you factored correctly and left the square term negative. So, you should have gotten, this as your factors. Did you guys get that? That is a 2 cosine x minus 1. I know they kind of leads together, so I do apologize. And then cosine x plus 1. Alright? Again, another California. You said both of them equal to 0, so that leaves you with a cosine x equals 1/2, and then a cosine x equals a negative 1. Where does cosine equal a positive 1/2?
Pi over 6. No, pi over 3.
Pi over 3. Anywhere else? 5 pi over 3. And we are writing all of the solutions. Are these equally spaced apart, like by a pi or by like a 2 pi?
Yeah.
No, they're not. If you recall from our unit circle, They're like here and here, so they're not equally spaced out. So what do you need to put after each one of them? 2 and pi. Yes?
I got cosine x minus 1 and cosine x plus.
You did the same thing I did. You forgot to carry the 2. That's what I did then. So I got a negative 1 out and a positive 1.
I put the 2 over the 2 and I got 1.
Yeah.
Where's cosine equal to negative 1?
Pi
At pi. Is that it?
plus 2.
So then you have a plus of 2 in pi. And then those would have been your solutions for that last one. Questions? Alright, let's look at the last 2 examples going back to your notes. The last method, and as I explained the other day, this is the method that you would use when you can't do any other method. It's kind of like that change everything to sines and cosines, you can't do anything else. It's like one of those. Okay? This is squaring both sides. That is that's the technique, strategy. We are using the restriction from 0 to 2 pi, and we have cosecant x minus cotangent x equals 1. Now, you need to put somewhere in your notes that when you use this method, you have to check for extraneous solutions. Okay? When you do this method, you have to check for extraneous solutions. You guys remember what those are?
Yeah.
What are they?
You plug in your answer back into the original equation and see if it comes out t.
Exactly. That's when you plug it back in, and if the left side doesn't equal the right side, then it's actually not a solution. Okay? So one good way to start, and honestly to make it easier on yourself, if you have the situation, you're going to square both sides, I strongly suggest that you put one trig function on the left and one trig function on the right. If it does not start out that way, like this one doesn't, move one of them. Okay? It'll make it a lot easier for yourself in the long run. Okay? So to start this out, we're going to add cosine to both sides. I mean, not cosine, cotangent x to both sides. So you'll have cosecant x equals a 1 minus cotangent x. Everyone good so far?
Yeah, it should be plus 2.
Yeah, why did you?
So that ain't clear. I thought I wrote a plus, but I guess the pen didn't mark it. Thank you. 1 plus cotangent x. It's not an identity because it's not squared. But what we're going to do now is we're going to square both sides. Okay? We are going to square both sides. So the left side is going to turn into a cosecant squared x. And then what are you going to have to do on the right side? FOIL. You don't have to write this out. I'm just doing it for the visual. What's 1 times 1? 1. 1 times cotangent? Cotangent times 1? When you combine like terms, that turns into a 2 cotangent x. What's cotangent times cotangent? If you're like, I don't think this is helping too much, okay? It actually is. Because by squaring both sides, we now have this equation. And we actually have part of our equation that we can rewrite using the other trig function that's in this problem. 1 plus cotangent squared x can replace cosecant squared x. And now we have all the same trig function. And we can use the other strategies. It started out simple, got a little ugly, but it's about to get real simple. Okay? So, get everything on one side. You guys go ahead and do that. Get everything on one side.
Oh, we didn't shift it.
Okay? So when you divide it, did you figure out where cotangent x equals 0? Pi over 2 and 3 pi over 2. But don't stop here. You have to check. Because we square both sides. We could have potentially created an answer that really is not an answer. So you check by plugging in. Old school plugging in. That's cosecant of pi minus cotangent of pi. It has to equal 1. Cosecant is the reciprocal of sine. What is the sine of pi over 2?
Wouldn't that be pi square root 2 over 2? No, 1.
Pi over 2. It's 1. So when you flip it, it's still 1. What's the cotangent of pi over 2? You said cotangent was 1 over what? X over y, cosine over sine? It's going to be 0. Does 1 minus 0 equal 1?
Yes.
So that works. You do the same thing with 3 pi over 2. What's the sine of 3 pi over 2?
1.
And is the cotangent at 3 pi over 2 0? Is
Yeah.
negative 1 minus 0 a 1?
No.
So that is the extraneous solution. Only pi over 2 is your solution.
There's always going to be one extraneous solution. I don't like that. Now I have to check it.
You're supposed to.
You want to
Now I gotta check both. I can't just find one right. That's too much work. I know, right? I agree with you.
All right. This one,
I submit.
we still got to do it the same way. We can't plug in any identities. We can't try to rewrite one in terms of the other. They're not being squared. So we're going to square both sides. I want you guys to do this one on your own. All right. It was already separated, so you start off by squaring, yes? So then you got cosine squared x equals sine squared x minus 2 sine x plus 1, right? So then, hopefully you recognize and change cosine squared x into 1 minus sine squared x. You got everything on one side after that point, yes?
Yes.
The ones canceled out. You took out a sign. We get 2 as well. 2 signs. Now, if you took out a sign, that would have been fine. But if you just took out a 2, not so much. Okay. So make sure you take out the full GCF. Leave you with a sine x minus 1. Set them both equal to 0. You'll end up with a sine x equals 0 and the sine x equal 1. Where does that happen? Either. This one. This one. But you gotta check them. You got 3. So that's why I can't say it's gonna be 1. You know, sometimes you may have more.
So now I got a 33% chance.
Exactly.
These odds are in my favor.
Not too much. What's the cosine of 0? 1. So what's the x value of 0? What's the y value at 0? Is 1 equal to a negative 1? So you know this is not a solution. Check pi. What's the x coordinate at pi? What's the x coordinate? What's the y coordinate at pi? Does that equal?
Yes.
Yes. Pi works. Last one. And these are easy because it's 1, negative 1, 0. Mm-hmm.
Not here, right?
What is the x coordinate at that one?
0.
What's the y coordinate here? Does that equal? And there are your solutions. Only on these do you have to check because when you square both sides, you end up, like I said, creating a potential wrong answer. All right? Questions on solving equations?